welcome to the last lesson of Module 4 about the geometric distribution. We'll finish up this lesson and then you'll be able to do all of your last bit and take your test. So the geometric distribution is along the same lines as the binomial, but there's one key difference. We'll talk about that as we go. It's not too hard, but it's related to, but different than the binomial. So the geometric distribution, we're going to calculate the probabilities and the parameters. We're going to do it all in one section. And of course, we're always going to be able to interpret them in context. So we have our essential knowledge, and the difference about geometric versus binomial. On binomial, we did a fixed number of trials and counted the number of successes. We're still going to have successes and failures, but on geometric, we're going to keep doing an experiment until we get the first success, until the first success occurs. It always kind of reminds me of when you can't find your keys. You keep looking until you find your keys. So that's kind of what I think of when I'm thinking about geometric. I keep doing something until it happens. Okay, I keep flipping a quarter until I get a heads. I keep buying boxes of cereal until I get the prize. And I don't know if they even do that anymore. I used to have anyway, whatever. Okay, so we're going to keep going until we get the first occurrence of success. We still have success and failure, and we have a fixed probability of success each time. Okay, and we'll have a formula for it. We're going to build that, and then we're going to find the mean is 1 divided by the probability of success, and the standard deviation is the square root of the failure divided by the probability of success. So we've got all that worked out. We'll figure that out in a minute. And of course, the last bullet is we always talk about it in context and put it on the units. Okay. So we're not going to talk about Miss Young and her amazing free throw ability tonight. Okay. Miss Young, we know. Okay. I'm sick of it too. Okay. So you're going to know, she's an amazing free throw shooter. You don't have to listen to her brag, and maybe that's why we're going to record, because I didn't want to have to listen to her brag about how wonderful she is. So hopefully that doesn't bother, don't tell her I said that. Okay, maybe she won't watch this video anyway. But what you don't know is that I'm pretty bad at it. I'm an ex-football player. My only athletic ability is running into people. I'm good at bumping into people and getting in people's way, which is great for an offensive lineman, which is what I was. I'm an ex-offensive lineman. So I have the ability to get in your way really, really well. Okay. But I can't make a free throw to save my life. In fact, I think I'm only about a 10% free throw shooter. Okay. I really am bad. Okay. So we want to figure out how long you're going to have to sit around waiting for me to finally make one. I don't know if you know who Shaquille O'Neal is, but you may not know he was a terrible free throw shooter too. Okay. So let's figure out what a geometric deal is. Again, I talked about this a little bit earlier. A geometric random variable, we do the same thing over and over until we get the first success. And so each trial is independent, and each trial has a probability of success, fixed probability of success, and their conditions are related. Remember, it was bins for a geometric. We're still going to have binary, success or failure. We're still going to have independent. Each free throw has no impact on the other. And the difference is we're going to be counting trials. There's not going to be a fixed number. We're doing trials till the first success. And then each one has a fixed probability. So it's bits and bins. Bits, we have a trials to success. In binomial, sorry, can't talk tonight. You had a fixed number of trials going in, fixed number of shots, fixed number of kids, fixed number, whatever. Okay. So we remember this one with bits and bins, these two with bits and bins. So how long will you have to wait until I finally make a free throw? If we all went to the gym and you sat there watching me knowing that I'm going to be a 10% free throw shooter. Well, we're going to let X be the number of shots that I needed and that I will take until I make my first free throw. So there is no zero. We start counting at 1. So the probability of me getting it on the first shot, it would be 1 out of 10. So I take a shot. Oh, I made it, done. 10% of the time that's going to happen. All right. So that means that's great. What about the probability too? Well, I have to miss, then I have to make, right? So if I miss the first one, The complement of 0.1 is 0.9. So there's 0.9 chance of me missing it, and then 0.1 chance of me making second, and I'm going to have to multiply them because they're independent. We can multiply them. So I'm going to take 9/10 times 1/10, and when I multiply them, it's going to happen 0.09, or about 9% of the time. So if we went to the gym and I started shooting free throws many, many times, about 9% of the time, I would make it on the second shot. Okay, you got that? Okay, so we're going to keep going because these numbers are pretty low. And what's going to happen is it's never going to get any higher. It's just going to keep tapering off. But overall, it's because we're going to go. I could keep going forever and ever, and eventually I might make one. Okay, so let's see about what if it was the third. Well, I have to miss the first one and miss the second, right? Miss two and then make the third. So 0.9, 0.9, and then 0.1. So I have 9/10, 9/10, and then 1/10. And that's going to occur 0.081% of the time. And there is no end number. It's going to be 1, 2, 3, and it could go on. I theoretically could be out there taking 200 shots, but it will go down. In geometric, always the first one is actually the most likely, but it might be pretty small. Okay. So the pattern is 9/10 to the 0 times 1, 9/10 to the first times 1/10. I think I said the 1/10 there. I'm sorry. 9/10 to the second times 1. Those are what we already did. If we went to 4, it'd be 9/10 to the third times 1/10. Do y'all see what's going on here? This exponent is one less than the number that I would occur, because I'm going to miss all of the ones up to the one I make, right? So I make the first one. I didn't have to take any misses. Here, I miss one and then make it. Here I miss 2, then make it. Here I miss 3, then make it, and so on. So I keep going. I'm going to miss the number, one less than number, and then make it on the last one. And that could be a really long time. Okay. If we calculate the table, we can go, and we made the first 3, I think, on the previous page. I can find the others. Let me show you how I got those others. Oh, by the way, there's also a graph of it. Okay. So when we were doing this with the binomial a little while ago, I can go to menu, down to probability, over to distributions. And we have binomial PDF at A, but if you keep going down, option H is geometric PDF. Okay, we want the probability. So we left off at 3. If I go in here, and I could use the formula, but the probability of success is 0.1, and the X value of 4, if I hit tab, would be the 0.0729. And I could keep going. If I wanted to go and figure out the probability of making 5, I would go back and change that 4 to a 5. There's only 2 things. You need the probability of success and the number of the first occurrence of the success. And that was the 6, that number right there, 0.06561, okay? And if I plot those, it would be skewed to the right. The first number, 1, will always have the highest probability, and it will taper off from there. It could conceivably take me 28 tries, but it's more likely that I'm going to make it earlier than that, okay? So let me jump back into the presentation here. So you know how to find a binomial using the calculator and a geometric. You should be able to find both of those probabilities, okay? So there's the table, and I could have kept going if I wanted to. And I used, I think I used Staplet or one of the apps to make the plot, okay? And it would track, you can see the first bar is 0.1, the next one is 0.09, and it tapers off from there. Every geometric distribution will look like this. It just, this first one might be higher or lower, depending on what the probability of success is, okay? So the only other thing is to describe this distribution, to do the center and all that. Well, I'm not going to build the formula. The center we talked about, it was on the other, was the definition would be 1 divided by the probability of success. So that mean would be take 1 divided by the probability of success, which is 1/10 or 0.1. So 1 divided by 0.1 is 10. And if I were to, it would take, on average, if we did this many, many times, went to the gym and had me start shooting free throws many, many times, it would average out to be about the 10th one where I made my first free throw. There's nothing unusual. The graph is skewed to the right. The shape is a characteristic that's always going to happen with geometric. My most likely value to hit is make it. My first one is on 1, although it's not very likely for me. And the standard deviation is, the formula was there, indicating that I would, if we did this many, many times, my free throw would differ from 10 by 9.487. So I was being specific, and I had the units in there. So hopefully you're just going to have those formulas are again provided for you. So your last assignment is to do some Khan Academies about geometric and binomial. And, you know, 4th place, baby. So, all right. Hope you have a great day.